So far, we have discussed pillar one of object oriented programming, which is encapsulation. As pillar two, we studied abstraction. Now it is time to study inheritance, which is pillar number three. Whenever we talk about inheritance, the first thing that comes to our mind is our parents. You will be inheriting many things from your parents. For example, maybe your face, your habits, your way of thinking, your way of saying, your way of behaving. This is inheritance in terms of anthropology. That is, in a social term, by inheritance, we mean we are inheriting something from our parents or maybe grandparents, some of the attributes, not only physical, mental attributes. For example, we also inherit home from our parents. Now, in terms of object oriented programming, this inheritance works in a similar way, where the children classes inherit attributes and methods from the parent class. Now, inheritance is not a silver bullet. It helps sometimes and it also hurts sometimes. Let's first discuss when inheritance should be used. When there is clearly is a relationship. For example, when I say dog is an animal, this statement is true because whatever properties animal has, those properties will be applicable to dog as well. For example, animal will be having some number of legs. It can be 2, it can be 4. Similarly, dog will also have some number of legs. For example, when I say human is a address, this statement is not true. Why? Because human will be living at some location. They will have some address, but human is not a address basically. So this is a relationship here is not true. Whereas in case of dog and animal, this is a relationship holds. So you can apply inheritance in the first case when there is clearly an is a relationship. Shared behavior across related types. If cat also inherits from animal, then whatever attributes are there in animal will also be inherited in cat. Similarly in dog as well. So there is a shared behavior across related types. Cat and dog are related because both are animals. Stable base class that won't change frequently. Base class is animal in this case, the parent class. So whenever you say superclass, whenever you say base class, whenever you say parent class, they are the same. For example, animal in this case is a base class. Subclasses truly specialized, not just reuse code. So, two things to understand. One is what is subclass and what is reuse of code. So, first thing is subclass is nothing but also known as children classes. So, a child class is also called as subclass. Not just reuse code. This is an important statement because generally people think that inheritance is because we need to reuse code. We will see an example of this. Even though there is a possibility of reusing code using inheritance, inheritance might not be a good fit. For example, address is not extendable by a human because human is not a address. So inheritance should not be used, even though human will be having some address attribute, but this attribute should not be inherited from address. So that's the point that inheritance should not be just used just because you want to reuse some code. There should be a clear is a relationship, then only you should use inheritance. Now, when does it hurt? It hurts when base class changes frequently, and this change will ripple to all the subclasses. For example, object class in Java is the superclass of every class in Java. Let's say tomorrow it's one of methods to string changes its behavior, or equals or hash code break the contract. If this thing changes, all the classes across all the code bases, across all the companies, across all the software will be impacted immediately as soon as that version is released and deployed. And hence, inheritance can cause pain when the base class is subjected to change very frequently. The ideology is that base class must be stable, then use inheritance. If the base class is changing very frequently, either we are not doing inheritance properly, some of the functionality should move to the children classes, or we should not use inheritance at all. That's the idea. Interviewers watch for over engineered hierarchies. When you do B extends A. That means B inherits from A. Then C inherits from B. Then D inherits from C. This is basically called as hierarchy. This is a hierarchy. From your grandparent, your parents, then you. And this is a hierarchy. We should not have over engineered hierarchies. We should not create long enough chains unnecessarily. If you cannot explain the inheritance in one sentence, reconsider your design. So, having considered inheritance, now let us take a practical coding example. So, here we are in the IDE, and we will be taking the example of dog and animal. And then we will take the example of man and address as we discussed already. So, let me create a new file called animal, which will serve as the base class or the super class. Now, this, let me close these other tabs. So, animal class, I will be writing like this. Let me make it public. Public class animal. And let's define one attribute, number of legs. So I will say private int number of legs. And this number will be set when animal object is created. So I can write like this, parameterized constructor, and it will accept the number of legs. So let me copy the variable, and we can write this dot number of legs is equals to number of legs. Now, I will be needing the getters and setters as well. So let me quickly write those. Getter is needed, setter is not needed, because once the animal instance is created, unless they are injured or decapitated, we don't need to change it. So let's assume that the animal is healthy, so we won't be needing a setter. So I will just write getter. So get number of legs, and this will return me number of legs. I will be using camel case here. So this will be the method name. So this is a getter, and setting we are doing in the constructor itself when we are creating the instance. Let me create the dog class. Dog is a animal, right? Dog is a animal. So I can write dog is a animal. So I can easily write dog extends animal. And as soon as dog is extending animal, that means animal is being inherited by dog, or equivalently dog is inheriting animal. So this attribute, number of legs, it is private to animal only. I can make it protected so that it is inherited by and its children. So that's why this attribute is now present in the dog class also. Now let me create the dog instance in the main class. So I will write animal dog is equals to new dog. And in the constructor, we need to define the number of legs. So number of legs, and I just will call super, and then I will pass number of legs. So as soon as I call super, then the parent class constructor will be called and animal will be created. So I can write 4, and then I can write system.out.println, then dog dot get number of legs. So I can use the getter method, and it should print me 4. Let's execute this. So it is printing 4. So from animal class, dog is inheriting some attributes which we are using in main. Now it can happen that some of the properties are private. So even if I write private, this number of leg is there in the animal class, and we are putting getter as well in this class only. So this code should still work. So let me execute it. So it is still printing 4. Now let's take an example of man and address. Why we should not use address for humans. So let me create a class human. And in this class, I will be defining. Now human will be having an address. So I can write address. And this address itself will be a class. So let me create address class as well, which will have some attributes like, let's take simple attribute only because we are understanding inheritance, not design patterns or full solution of the problem. So I can define like this, maybe floor and then street name, just this. Now, once this is done, this human will be having address. And in the main class, let me create its instance. So in human, we need to define this as well. So human, and let's say at the time of creation itself, I will pass the address. So I can write this dot address is equals to address. And let me make it public, though it won't matter because every class is in this package itself. So here, when the creation of address, we need to define the parameterized constructor for address class as well. So it will be having floor and street name as well. Now I can simply do this dot floor is equals to floor and this dot street address is equals to street. Street name is equals to street name. In the main class, I will first create address because for the creation of human, I will need address entity to be passed, and that's why I'm creating this. So address one is equals to new address, and let me pass floor is one and street is some maybe MG street, MG road. That's all. And then I will create the human. So human one, new human, and here I will pass the address. That's all. Now here maybe I can print the human as well. So when I print the human, I need to print the address. So I can just write, I can override the toString method inherited from the object class. So I can write return whatever this address is. I will call toString on this. Similarly, I can override in the address class as well so that this address can be printed properly. So I can write floor will be floor and street is equals to street name. That's all. So now once we are done with the definition of toString, we are done overriding toString and have set all the attributes. Let's just print human. So I can write system.out.println human. And as soon as I print human, it will go to the human class. It will see for the toString and it will see address.toString. So it will go to address class and will see the toString. It is written in floor and street name, which we are setting in the main class. So it should print one and MG road. Let's try to execute this. So it is printing correctly. Now one more thing. If I do, now one more thing. Human is having address and address is having some attributes. In the previous example, we saw that animal attributes are inherited by dog class. So if I remove this variable and write like this, extends address, then ideally whatever attributes are there in the address class will also be there in the human. So these values are there. And then if I set like this, I call super, and here I will be accepting floor and string name, street name. So I can pass this in the constructor. So now super, that means address is constructor will be called and the values will be set. And whenever I am printing human, I am just calling address dot toString. So I can directly write super dot toString. So I can do super dot toString. Now, if I run the main class, I just have to change few lines. That's all. This code should ideally work and should print the same thing. So you see, same value is printed. But does it make sense? Just because human was having address, we did not include address. We did not prefer composition. Where human is composed of address, we preferred inheritance. This is not a correct way because human is not address. And that's why this way of writing, although it is working, is not correct because this is causing a lot of confusion whether if human is a address or not, which is not. So extend should not be there. So the previous example was correct, and this example demonstrate human should not extend address.